You're here because you want to master acids, bases and salts with a University of Cambridge graduate. Let's begin. Hi, I'm Brendan and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today. So we first need to know the definition of an acid. An acid is a chemical substance that actually dissociates in water to form H+ ions. Take note of this key term H+ ions because this is actually what gives the acid its chemical properties. It is usually the H+ ions that will dissociate out and does further reactions as well. And we'll be mentioning this later on as well. So acids can be actually monobasic, dibasic or tribasic, okay, depending on the number of H+ ions that can dissociate from it. And we'll be touching on this as well later on, but basicity of an acid is actually an important concept that you have to be quite aware of. So let's look at some of our examples of acids. For example, hydrochloric acid, right? It's HCl aqueous and you'll dissociate in water to give H+ aqueous and Cl- aqueous. Notice how one H+ ion came out from one molecule of HCl, so we call this a monobasic acid. Let's look at nitric acid, another common acid, right? This nitric acid is HNO3 aqueous and you'll dissociate to give H+ aqueous and NO3- aqueous. And this is also a monobasic acid. Now if you look at sulfuric acid, this is an example of a dibasic acid. So if you look at H2SO4, right, sulfuric acid is actually a dibasic acid, right? And each molecule of H2SO4 will actually give two H+ ions that dissociate from it, right? So that's why we call it a dibasic acid. Phosphoric acid is an example of a tribasic acid. H3PO4 can dissociate in water to give 3 H+ aqueous plus PO4 3- aqueous, right? So do pay attention to some of these common acids because they are very commonly asked in your exams. And then we have ethanoic acid. Okay, ethanoic acid is an example of an organic acid, right? And this is actually a weak acid that partially dissociates in water to give H+ and an N ion as well from the organic compound. We'll further touch this in our organic chapters. Usually this is covered in secondary 4, right? And this is an example of our carboxylic acids. But in general, all our organic acids are weak acids here. Let's move on to our bases or our alkalis. So the definition of an alkali, right, is a base that is actually soluble in water. And alkalis tend to dissociate in water to form OH- ions. So kind of like an acid, but the opposite of an acid. Instead of giving H+ ions, you give OH- ions. And OH- ions are responsible for the chemical properties of these alkalis. Our bases, they tend to be metal oxides and metal hydroxides. Alright, these tend to be insoluble oxides and hydroxides. And our bases, by definition, accept H+ ions. And remember, H+ ions came from acids. So if bases are able to accept H+ ions, generally, bases are able to react with acids. So the definition of a base is that it can accept H+ ions. So let's take a look at some examples of our bases. Copper 2 oxide, alright, tends to be insoluble, and since it's a metal oxide and it is insoluble, it is a base but not an alkali. Let's take a look at the next one. Sodium hydroxide, a very common alkali, right? It's able to dissociate to give Na+ aqueous and OH- aqueous. It is soluble in water, alright, so it is a base and an alkali, right? Now let's take a look at ammonia, another common base, alright? So ammonia actually is slightly soluble in water. It partially dissolves in water to give NH4+ aqueous and OH- aqueous, right? And you must know that sometimes your alkalis, right, can react with water, alright, to give OH- ions. This is a very common pattern, especially for some of your like weak alkalis. Alright, now let's take a look at salts. So salts are generally these ionic compounds that usually compose of a positive metal ion and a negative non-metal ion. And salts are generally the product of reactions from your acids, right? And the way to think about how a salt is formed, right, from an acid reaction or a base reaction, right, is to always think about ions and how they swap around for the reaction, right? So you will see some examples later on, but in general, right, you will notice that there is one cation and one anion that doesn't really participate in the reaction, and from the product of the reaction, they will just come together and form the salt. Let's deep dive into some of the properties of our acids. So acids tend to turn our blue litmus paper red, alright, and they have a pH of less than 7. So they generally will turn our pH indicators to the acidic colors. So examples of pH indicators are like your universal indicator, right? This turns the universal indicator to red, orange, yellow, right? Depending on the amount of acidity, right? And methyl orange can turn from orange to red because red is the acidic color of our methyl orange. And there's plenty of other pH indicators out there, but in general, they will just turn the pH indicators into the acidic color. Then our reactions of our acids include acid plus metal gives salt plus hydrogen gas. So for example, if you have a reaction of hydrochloric acid with magnesium solid, right? Magnesium is a metal, so in the end you will form magnesium chloride, right? And you will also form hydrogen gas. Part of your syllabus is also knowing how to form your ionic equations, and in general, some of these ionic equations are very simple, alright? You can kind of memorize them, okay? And for acid plus metal reactions, it's generally H plus aqueous, again because it is the H plus ion of an acid that reacts, right, with the metal itself. And this will form magnesium 2 plus aqueous, which is the metal cation plus hydrogen gas. Acids plus bases can give salt plus water, right? So for example, if nitric acid reacted with magnesium hydroxide, right, and you want to form a balanced equation, you should know that the product is a salt plus water. The salt would be magnesium nitrate because the magnesium cation and the nitrate anion doesn't really react, and they'll combine together, and your water is also formed as a byproduct as well. So for our ionic equations, we generally will use H plus aqueous plus, in this case, magnesium hydroxide. This is a solid, so we don't need to break it apart as if it's in an aqueous form. It's a solid, so it stays in a solid form and reacts as a whole, okay, and reacts to give magnesium 2 plus ion, right, and also water as the byproduct in the ionic equation. Acids can also react with carbonates, right, to form salt plus carbon dioxide plus water, right? So an example equation would be, for example, hydrochloric acid reacting with calcium carbonate. So if hydrochloric acid reacts with calcium carbonate, this would give you calcium chloride as a salt because the calcium cation and the chloride anion is not really reacting. Okay, and then you will form CO2 and you will form H2O. And make sure to balance your equations. If you look at the ionic equation, again, the H plus ion is the one that reacts. And since calcium carbonate is a solid, right, calcium carbonate would not be broken down in the ionic equation. And the result of this, you get the calcium ion plus you get H2O plus you get CO2 gas in the ionic equation. So it is very important to go and memorize your reactions of acids. I repeat again, you must memorize the reactions of your acids. This is very important, okay? Because this is very fundamental knowledge that you need to know as a chemistry student. You need to know that your acid can react with and then it will give product A, B, C, alright? It is expected of you to know, and this is useful, especially if you want to go and balance equations later on as well. Throughout this lecture, you kind of hear me talking about strong acids and weak acids, or sometimes weak acids, right? But what's the definition of a strong acid, or what's the definition of a weak acid? Strong acids fully dissociate in water to give H plus ions, right? They fully dissociate, means 100% of the acid will dissociate to give the H plus ions and the other anion. So for example, sulfuric acid, right? All the sulfuric acid would dissociate in water to give H plus ions here, and also the anion. Weak acids, on the other hand, will partially dissociate in water to form H plus ions. So if it's partially, it means it's not 100%. As long as it's not 100%, it is considered a weak acid. So for example, your organic acids, all your organic acids are weak acids. For example, ethanoic acid, CH3COOH, can partially dissociate to give H plus aqueous, and CH3COO minus anions. Let's move on to the properties of our bases or alkalis. So your alkalis tend to turn red litmus paper blue, and they tend to have a pH of above 7. So they'll turn your pH indicators to the alkali colors or the basic colors. So for example, universal indicator will turn from green to blue, purple or violet depending on how alkali the solution is, and it will turn meta orange from orange to yellow. Next, okay, our reactions of our bases. So we again also have to memorize the reactions of our bases. We've already covered acids plus bases to give salt plus water. Okay, but a new reaction, which is a very commonly asked reaction, is alkali plus ammonium salt can actually give you a salt plus water plus ammonia gas. Okay, and ammonium salt is any compound with the NH4 plus ion inside. Right? So for example, sodium hydroxide can react with ammonium nitrate, right, to give sodium nitrate, which is the salt, because the Na plus ion from sodium hydroxide and the nitrate ion, anion, does not react, okay, but they will just combine at the end. Okay, you also give water plus ammonia gas, and you got to make sure the whole equation is balanced as well. For our ionic equation, right, we know the OH minus is responsible for the reaction, so it's going to react with the ammonium ion, and this will give water plus ammonia gas. So just like how acids can have strong acids or weak acids, your alkalis can also have strong alkalis or weak alkalis, right? So strong alkalis fully dissociate in water to give OH minus ions. So for example, NaOH aqueous will give Na plus and OH minus ions, and we use a full arrow here. For your weak alkalis, they partially dissociate in water to give OH minus ions. So a very common one is your ammonia gas or aqueous ammonia, right? It can react with water itself to give, okay, we don't use a full arrow here, we use a reversible arrow over here, right? And this will actually give you NH4 plus aqueous plus OH minus aqueous. Lastly, right, we also have to know the natures of our oxides. In total, there are 4 types of oxides that you need to know. There's basic oxides, acidic oxides, amphoteric oxides, and our neutral oxides. And I'm going to teach you how to identify each and every one of them. For our basic oxides, these tend to be our metal oxides, right? So if you see a metal oxide, okay, it tends to most likely be a basic oxide. Okay, and this means that they actually behave like alkali, means they can react with acids. So for example, our sodium oxide, our potassium oxide, our calcium oxide, these are all basic oxides. Acidic oxides, on the other hand, are non-metal oxides, and they tend to behave like acids, so they can react with bases. For example, our carbon dioxide, our sulfur dioxide, our phosphorus oxide. These are all acidic oxides. Next, we have our amphoteric oxides, and this is the crucial one that is often tested as well, and most students often forget about it. Your amphoteric oxides, they have only 3 examples that you have to go and memorize. These amphoteric oxides behave like alkali or an acid because they can react with both acids or alkalis, right? And how to remember this is your ZAP oxides. Okay, your zinc oxide, your aluminium oxide, and your lead-2 oxide. This is your ZAP oxides. Lastly, is your neutral oxides. Okay, there's also only 3 examples you have to memorize, and because they are neutral, they just do not react with acids or alkalis. So for example, water. Water is also an oxide, right? But this is neutral, as you know, because you drink water all the time, it's not acidic or alkali, or else you would die by now, right? The other one is carbon monoxide, and the other one is nitrogen oxide. Right, so these 3 examples are your neutral oxides which you have to memorize. If you enjoyed today's video, do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.